Here's June 2015, number 36 and 37. Number 36 says, an application developer released a new app to be downloaded. The table below gives the number of downloads for the first 4 weeks after the launch of the app. Write an exponential equation that models these data. So, two ways you could do this. You could type in list 1, list 2, after you'd already hit stat when you type it into list 1, list 2. You'll hit stat again. You'll scroll over to calc. And I believe it's the option 0, so you have to scroll down quite a bit until you see exponential regression. Okay, and they'll give you the equation that way. But we can do this without a graphing calculator. So we know that an exponential equation looks like this: y equals a times b to the power of x. So your a value is your y-intercept, which they don't actually show on the table, okay, but that would just be when x is 0, what's your y? So let's figure out the pattern first. So from 120 to 180, 180 to 270, since it's exponential, it's going to be multiplying by some factor each time. And to figure that factor out, what you're going to do is take the second term, 180, divide the first term, 120, and you'll end up with 1.5. So that is your growth factor. Each time you're multiplying by a factor of 1.5. So what we could do is work backwards, and to do that, we would take 120 and divide by 1.5, and 120 divided by 1.5 would give us 80. So 80 would be your y-intercept. Okay, so at 0 weeks, you've already had 80 downloads. So your equation is actually going to be y equals, remember your a value is your y-intercept, so that is 80, times your b value, your growth value. Your growth value is what you're multiplying by each time, that's your 1.5, and then you're going to raise it to a power of x. So this is the answer for the first part of this question. Use this model to predict how many downloads the developer would expect in the 26th week if this trend continues. Round your answer to the nearest download. So all we have to do is plug 26 in for x because it's a number of weeks. So we have y equals 80 times 1.5 raised to the power of 26. If I type that in, I get 3,030,140 downloads. Okay, and they want it to the nearest whole download, so that is your answer. Last part of this question, would it be reasonable to use this model to predict the number of downloads past 1 year? Explain your reasoning. Well, no, it would not be reasonable because you're looking at an app, okay? After a year of this new app being out, you're not going to have exponentially more downloads. Think of something in the past that you used to play all the time, like Candy Crush or something. Okay, when it first came out, it was very popular and everyone was downloading Candy Crush, but then at a point it stopped. Not many people were still downloading this new game because it was older and other things came out. So, no, and you could say what I said in your own words. You could say that the popularity of an app typically changes over time. Okay, it's not just going to consistently become more and more popular with consistently more and more downloads. At a certain point, it's going to level off. You're not just going to keep having an increasingly amount of downloads. Number 37. A football player attempts to kick a football over a goalpost. The path of the football can be modeled by the function h of x, where x is the horizontal distance from the kick and h of x is the height of the football above the ground. when both are measured in feet. On the set of axes below, graph the function y equals h of x over the interval 0 less than or equal to x less than or equal to 150. This is huge. This tells you what your x values need to go from. They have to start at 0 and go all the way to 150. Okay, and if you figure out what you should count by, use the graph. Use the whole graph that they give you. So if you do that, you could count each unit would be every 5, okay? And so I'm just going to do that very quickly. Okay, so I labeled my x-axis, and rather than writing 5, 10, 15, 20, 25, 30, I just labeled every 15, 15, 30, all the way up to 150. Okay, so the reason I know this again is because of the interval that they tell me, 0 to 150, which means you're going to have to change your window settings on your graph, because your window settings typically go from negative 10 to 10 in the x and the y, and this needs to go from 0 to 150 in the x. So you can change your table or your window settings on your calculator, okay, by hitting window, and it's in the top of your calculator. I believe it's next to y equals, okay, and you can change your x from your x min of 0 all the way to 150, and then you can look at the graph and figure out how high your graph will actually go. When you do that, you'll figure out that your graph goes as high as 25. So you can label your y-axis accordingly. Okay, so I labeled my y, and really each unit is 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Okay. So now I'm going to look at my table, and I'm also going to have to change my table settings because typically your table starts at 0 and it goes up by 1s. Okay, so what you'll see is that you won't necessarily have nice numbers unless you change your table settings to change in TBL, change your table settings, and you're going to count by 15. Okay, and you should start with 0. So 0 is 0, 15 is the point, 9, which is right here, oops, 30 is up to 16, so that is, let's see here, right here, 45 is at 21, 60 is at 24, 75 is at 25, whoops, and 90 is at 24, okay, and then it's going to do the same pattern again because it's a parabola. So 105 will be right here at 23, 120 should be at 16, 135 should be at 9, and 150 will be back down to 0. So now we connect the dots, and that is the path of the football going over the goalpost. Okay, and let's see, x is the horizontal distance, so this is horizontal distance h of x, which is your y, is the height of the football above the ground. Okay, so determine the vertex of y equals h of x and interpret the meaning of the vertex in the context of the problem. Well, the vertex, the highest point where everything is repeating around, is the point 75, 25. Okay, and this is where the football reaches its highest point. The goalpost is 10 feet high and 45 yards away from the kick. Will the ball be high enough to pass over the goalpost? Justify your answer. Okay, well, 10 feet high, so that is your y value. Your x value, it's 45 yards away. However, 45 yards, we're dealing with feet, so we need to convert our yards into feet. So if we have, I'll write this up here because I'm running out of room down there. So if we have 45 yards, we want to know how many feet. Well, we know that in 1 yard there are 3 feet. So if I multiply 45 by 3, I will end up with how many feet I have. So 45 yards converts into 135 feet, and again, I just multiplied 3 by 45. So it says, will the ball be high enough to pass over the goalpost? Okay, well, let's look at our graph. So if it is 135 feet, that is right here, okay? And we're going 10 feet high, which is right above where our point really is. Okay, so will the ball be high enough to pass over the goalpost? Well, the ball is my red line, the parabola, and the goalpost is slightly above, so no. The goalpost is 1 yard higher than the ball at this point. So the ball did not go over the goalpost.